So here we have our example, dy over dx is equals to 2e raised to x minus 0.5y, where our y of 0 is equals to 0. So we will find the value for y of 1 at step size h is equals to 1 using Runge-Kutta fourth order method. So here is our general formula for Runge-Kutta method. So we have y sub I plus 1 is equals to y sub I plus 1 over 6 multiplied by k sub 1 plus 2k sub 2 plus 2k sub 3 plus k sub 4 multiplied by h. So for us to get the values for this case, so we have here their formulas. So first, we will set our initial values for I, x of 0, and y of 0. So we have our I is equals to 0, our x of 0 is equals to 0, our y of 0 is equals to 0, and our h is equals to 1. So first we will calculate the value for k. So we have here k sub 1 is equals to function of x of 0 and y of 0. So we have function of 0 and 0. So just substitute these values here in our given function. So we have 2e raised to 0 minus 0.5 multiplied by 0, so just cancel this. So we have 2. So since we have our value for k sub 1, so we can get the value for k sub 2. So k sub 2 using this formula, so function of x sub 0 plus 1 half multiplied by h and y sub 0 plus 1 half multiplied by 2, which is our k sub 1 multiplied by h. So we will get function of 0.5 and 1. So just substitute. We have 2 e raised to 0.5 minus 0.5 multiplied by 1. So we will get 2.7974 for our k sub 2. So next, for our k sub 3, since we have our value for k sub 2, so we will use this formula for k sub 3. So we have function of x sub 0 plus 1 half multiplied by h and y sub 0 plus 1 half multiplied by k sub 2 multiplied by h. So by substituting these values, so by calculating this, we will have function of 0.5 and 1.3987. So just substitute these values in our given function. So we have 2e raised to 0.5 minus 0.5 multiplied by 1.3987. So we will get 2.5981 for our k sub 3. So now for our k sub 4, for us to calculate our k sub 4, we have our k sub 3. So we will use this formula. So we'll have f of x sub 0 plus h and y of 0 plus k sub 3 multiplied by h. So we have function of 0 plus 1 and 0 plus 2.5981 multiplied by 1. So we have function of 1 and 2.5981. So we just substitute. We have 2e raised to 1 minus 0.5, 2.5981. So our k4 is equals to 4.1375. So since we have our values for k sub 1, k sub 2, k sub 3, and k sub 4, so we can now calculate for y sub 1. So using this formula, y sub 1 is equals to y sub 0 plus 1 over 6 multiplied by k sub 1 plus 2k sub 2 plus 2k sub 3 plus k sub 4 multiplied by h. So just substitute the values. So we have 0 plus 1 over 6 multiplied by 2 plus 2 multiplied by 2.7974 plus 2 multiplied by 2.5981 plus 4.1375 multiplied by 1. So we will get our value for y sub 1, which is 2.8214. And this 2.8214 is our value for y of 1. And to calculate the value for x sub 1, we have this formula x sub 0 plus h, which is 0 plus 1 is equals to 1. So if you want to calculate for y of 2, so just do the same procedure, just change the value for our I. So our I will become 1. So our x sub 0 will become x sub 1, which is this. Now our y sub 0 will become y sub 1, which is this. At the same step size, h is equals to 1.